start again. It's a redskin.
Hello and welcome back. And in this video, I'm going to be taking a Java live mock and I'll be taking interview of Krishna. Krishna is a 3.9 years of experienced developer. His main skills are Java, Spring Boot, Microservices, and these things. Basically, he's a Java backend developer. So anyone who is having experience between 1 to 7 years, I think you can follow this interview session. And most of the questions that I have kept in this interview are from Spring Boot, Spring Framework, and most importantly, Microservices. And also, I think I kept some Hibernate questions as well. So my primary intention of making this interview was to emphasize the microservices questions so that people from my community can be benefited out of it. So yeah, so if you are straight away over here for the microservices questions, you can go to this timestamp. But if you're here to watch the entire interview, please proceed step by step. And the first 20 minutes of interview was more on the Spring Boot and some REST API questions. And then I started with the microservices. So this is the round of Spring Boot and microservices. So another video I'll be posting on core Java maybe after a week or so. Okay guys, before I start this video, we do put a lot of efforts when we make this kind of videos. So I really need a little bit of support from you guys. So if you like this video, make sure to like this, only if you like this video, as I always say. And do subscribe to the channel for more contents like this. And do share these videos with your friends if you really can. That can help me to grow. And yeah, so let's just invite Krishna to the interview and let's just get started. I hope that you guys will find it helpful. Let's just get started. Let's just start with some of the basic questions, Krishna, so that you can settle down a bit and then we can just try digging in a little bit. Okay, so let me ask you a really simple question. Tell me the difference between @controller and @REST controller in Spring Boot. What is the basic differences?
Right. So @controller and @REST controller. Basically, these annotations are used to mark classes which handle requests which are coming through the client. Right. Client can be a browser, or client can be Postman or something like that, or another application. So these annotations are used to mark classes to basically handle those requests. And these requests are coming in through the front controller. But the difference between controller and REST controller specifically is REST controller specifically only deals with REST-based requests. Like, it is a specialized annotation of @controller. It means which it is a combination of @controller and @response body. So all the REST-based requests are REST-based requests through all the methods are handled through REST controller, and controller is more of a generalized.
Krishna, only one thing. @response body does what? Like, how it is special?
Right. So when we mark any handler method or any class with @response body, what we return on that handler method, that basically is as it is returned. So like we will have in the case of a REST-based endpoint, we will return it as a JSON, right? In the case of a web-based request, it will be returned as a string basically. So that's like the response body part. And for coming back to the controller part, controller is like generalized variation. So we can also return using view resolver, we can resolve web pages when we return strings of web pages. So that can be done.
So @REST controller is a combination of @response body and @controller together. And that basically helps us to return a JSON string instead of a logical view name that you basically resolve through the view resolver. Perfect. Bang on. So let's go with the next one. Okay, I'll ask you another simple question. Tell me how is Spring Boot application bootstraps? Just tell me when you just run a Spring Boot application. Okay, your Spring Boot application starts. For an example, what happens for a web-based application, what happens for a standalone application, what happens for a reactive application. When you start, something should be happening behind the scene. Just tell me your understanding, Krishna. Okay.
Right. So when we basically create a Spring Boot application, either through IDE or Spring Initializer, the main class, right, is annotated, and the main method is annotated with @Spring Boot application. Not the method, actually, the class is annotated with Spring Boot application. And that Spring Boot application is a combination of multiple annotations. One of them is component scan, another one is enable auto configuration. I think the third one is @configuration. So what it does is, and I think specifically with the bootstrap related thing, component scan and @enable auto configuration is what helps the Spring Boot application auto configure. And like I think in one of your lectures you had mentioned that Spring Boot is a very opinionated language, so it does a lot of auto configuration, or a lot of dependencies are auto configured when we start, for easy building, so the application is up and running very quickly. And we have annotations like conditional on mean, conditional on missing bean, conditional on property, conditional on class. So all of this together helps in getting the application together. Now, the second part of the question that I'm not sure about, that what is the difference in the bootstrapping?
What I mean by that is, Krishna, like when you start a standalone Spring application, the way Spring works is it uses some container behind the scene where it keeps all the beans. So for an example, if you're using a non-web-based application, a standalone application, or a IoT application, you'll be needing a normal application context, maybe annotation config application context or something. But let's say you are using, you are having the web dependency in your class path, then you'll be having a web application context created behind the scene. And if you're using a reactive app, it will also create a reactive container behind the scene. So that's what I said, like, based on the type of dependency you are specifying behind the scene, accordingly, a container will be created behind the scene as well, where your controller, beans, component mark classes, service mark classes, different handler mapping stuff, everything will be like, inside there. And Spring Boot uses all those specialized bean to configure your application, what we basically create through the auto configuration. Okay, that's fine. So basically the magic happens through that at Spring Boot application, isn't it? We don't have to configure anything. Things will be auto configured, and Spring Boot takes care of a lot of different things, and the magic happens. Perfect. So another simple questions to get started with, and then I'll keep digging in. All right. Okay. Tell me the best practices. Tell me the best practices of, what should I ask? There are a lot of best practices. Okay, let me just term it in this way. Whenever you're building any REST APIs, okay, what are the best practices you should be following? Let's say I'm giving you a task to create a REST API, right? So what are the standards that you'll be following to build an API? What things that you'll be keeping in your mind? Just explain me each point properly. Okay, I will be doing this, I'll be doing that, and this is why I'll be doing it. Okay, let's get started. Yeah.
So if I get a task to create a REST API or multiple REST APIs, the main important reason behind best practices is that I am creating REST APIs which is used by developers or non-developers within the organization, outside the organization, maybe within my organization, and different teams also. So best practices are a way to create a common ground for them to use these REST APIs. Now, within the best practices for REST API, we have something called as a Richardson maturity model, which gives levels on the basis of how mature your REST API is. But if I go deeper, like instead of going into the maturity model levels, if I specifically take care of the components, so the first thing that I would specifically prefer as a best practice is the versioning, because REST APIs, like based on how the application matures, the REST API will also mature, and we will have to version it. And in versioning also, we have multiple parts. Like we cannot have directly a major update each and every time. We have major updates, we have minor updates, we have patches also to fix existing bugs. So the versioning should be managed in that way, and it should be properly documented. After how, even I think in some of the REST APIs, I've seen that in the URL itself, like in the handler methods, to enable easy moving from one version to another, like they keep both versions active for some time, and then in the URL they have v5 active and v4 is also active, so that also works.
Okay. Now here, I just want to stop you a little bit. I want to hear like what exactly mean by versioning. Why do you need that? Let's say that Krishna, I told you to create a REST API for me. You have created an API and told me to use it. Okay.
Right.
Let's say then in the very next day, I as a client will tell you like, Krishna, I want these properties to be added in your API should have these things in your JSON payload, what it is returning. So you can go ahead and can change that API, right? That existing API that you have, you can go to that particular API and you can make it return one more properties inside it. So what is the need of that versioning thing? Can't we just simply change the existing API?
That is very risky, I would say, because
why it is risky?
Right, if we already have a REST API which someone else is using, they would have modeled their methods, or they would have modeled their REST calls on the basis of the response body they will receive, the request that they are sending, and all the basically moving parts. And if we change any part, then and that is not informed to them prior with notice, then that can break their code. So
on spot, yeah. That's the reason, because the consuming application can break if you don't inform them. So if it is your internal team, you can just say, hey, I'm just adding one more properties to the next team who's sitting in the next queue. But if it is some third party people are using it, it's going to be very risky. Perfect. Versioning is one point you said. Second point you said, like, take care of the recharge and maturity model. I don't want to get into that, but I understand that what do you mean by it. Go to the next point. Like, what are the other things you should be taking care of?
Right. The next thing, like you mentioned, response request body. So this is coupled with another point, documentation. So with it, when we have so many versioning of REST APIs, documentation for each version and for the REST API, like what method, what URL, what response code will be received, what will be the response body, request header, request body, all the moving parts should be covered and examples should be provided for the expected. So that everything is also very important with REST APIs. And with respect to the response body, response code also, we have certain best practices. Like within REST response code, we have series. So 200 series is for success responses, 300 is for redirection, 300 series.
Yes.
400 is for client side errors, 500 is for server side errors. So these things also should be maintained. Like we should not use something else. Like for example, if 302 is for redirection, we can't send it for a success response.
Perfect.
That is something which needs to be taken.
Response code, what we are responding with, the type, the XML type or the JSON type, that should also be restricted. So this couple of points I'm taking away from this point. Okay. And also you said like we should be mentioning our API in a proper documented way, so that the guy who is asking for or who is hitting the request, he should be sure like, okay, this is going to have this thing in the header, this thing in the XML or the JSON request, the content type, what he is sending with the request, we should be properly documented with the documentation, so that we should be sure like what we are hitting and what we'll be getting back, and what is the response code we'll be getting back. Right. Perfect. Okay, next point, Krishna. Is there anything else?
There are actually a lot of things.
Yeah, go ahead. Yeah.
Right. You mentioned content type. So content type is also something within the request body. What we are sending, the content type, that is also something which the REST APIs should be careful of declaring. Like if they are expecting JSON type of request body, then that should also be mentioned. And if they are flexible, that should also be something that should be covered and maintained. Similarly with the response codes, because with the response, any other application which is using it and it is expecting a response, then they will have to construct their application around the response code. So if we are returning, for example, XML based response, then that should also be covered. Similarly, one more, I think, very important point is the error part of things.
Yes.
So if in case things are not like provided in the way that was documented or that was provided, then it should be handled in an appropriate manner. Error responses should be meaningful enough to convey what might have been wrong, so that the developers on the other side or the users on the other side can easily debug it. One more thing, like very basic, is that because REST APIs are REST basic methods, so statelessness should be maintained.
Perfect. And what do you mean by statelessness?
Statelessness basically means that we should not save a state of a particular request from one request to another.
Why not?
No data. That is like founding principle of REST, that it should be.
Let's say, I will make sure, like, if a request is coming to me, somebody is giving his authentication details, I'll create a cookie, maintain his state in my computer, and next time I'm sure, like, whenever he is hitting a request, the request will become to the same machine where I'm maintaining the user state. And with that cookie that I have given to the user, I can identify this is the same user, and I can authenticate him and can proceed further with the request. What's wrong with this approach? Why should I make it stateless? Why should I not maintain the state of the user in my machine? Why it is recommended to make it stateless?
I think this example, like what you mentioned, is perfectly fine. Like and I think a lot of organizations have this mechanism where they use certain cookies to identify certain part of the data of the user. But where it becomes an issue is where we are saving, like the request itself is becoming so bulky that we are not transferring like an identifying key or a token to identify the user. We are populating the request itself with a lot of data to identify itself. Like within the request, we are transferring all data to identify itself.
What's wrong with the web application? Also, we are doing that. So how do you think it will give an impact whenever you're creating a REST API?
That will impact performance
think about a distributed system, microservices environment. If it is a microservices environment, you never know, right? So here in a monolithic application, you have only one machine. So you know that that machine only will handle that request. So you can store a cookie, things will go fine because same machine will handle the request in the next time also, you are very sure. But imagine a microservices environment where you don't know where the request will go. Let's say there is one service, that service has 5 instances, and those have been configured with a gateway. Gateway can route the request to any of the machines, right? So if, let's say, first time the request come and the gateway is sending it to the machine A, there you are maintaining the state to authenticate the user. You are not sure, like the next time the request will be going to the same machine. Okay, so if you're maintaining the state in that machine, if the request will go to another machine right now, So how that machine will be sure about like what is the state of that particular request? That's why we should not maintain the state. We should make it stateless, because most of the time REST APIs will be used in the microservices environment. So how will be maintaining the state then? How we can deal with the authentication as you are making the REST API stateless? So how you'll be maintaining this authentication thing? Because you cannot create a cookie or a session, right? So any specific thing you can do about it?
We can have, like Abhilash, there is one thing I wanted to note in the example you were quoting. So in even microservices environment, if they are connected to the same database, then in that case, the request, if they are sending a token, they will be able to hit the database to get the user details. So in that way, I think it is possible.
But do you think the microservices will be connected to one database? Is it really a pattern or an anti-pattern? It's anti-pattern.
Right.
So the solution will be you have to make it stateless, and you will be achieving it through token, maybe a jot token, you know about it, and or a auth thing you can implement. And you have to make it token-based authentication, not cookies or session-based authentication. But the point is spot on. Like it has to be stateless. Perfect. So many reasons you have given. Okay, few more reasons. And right now I want to just quote two major takeaway from the things that Krishna has quoted. One is exception handling should be done properly. Second thing, the thing should be that the REST API should be stateless in nature. Perfect. Any other thing, right, Krishna, you want to add?
Other things which we can add is like we have REST endpoints which have security also enabled. So in that case, we have to mention that and specify that in the documentation or to the developers that this particular endpoints will require security. What type of security? Because within security also, like you mentioned, there can be basic authentication or like token based or like jot based token. So there are various ways to do that, and that also will need to be documented.
And you can also maintain SSL or something. You can enable it with your request, because the hackers cannot get into your request and can steal your data. Perfect. Very nicely answered. One last thing, Krishna. Let's say you are designing a REST API. Okay. And let's say slash book. And you're fetching a lot of books. It's going to get you all the books from your DB. Let's say there are thousands of book objects available in your DB. So when you are returning, somebody is hitting slash books to fetch all the books. So how you will be dealing with that? Will you return all the 1,000 books object that you have in your DB in one go and you'll expose it as a JSON, or you will be following some other technique here?
Right. So this what you mentioned specifically comes under like techniques like sorting, filtering, and pagination. So
perfect. So pagination will be a right thing. So you can send the book object to the person who is requesting for it in chunks, and you can give him an option. Let's say first shot, I'll be giving you 10 books or 100 books. Next shot, another 100 books. At a time, if I'll be doing all the operation and giving him all the books, it will not be a good option. So pagination will be a right option, and it should be implemented when you are dealing with any REST APIs. Right. Spoke around 15 minutes on these questions. Perfect. Let's go to the next one. So let me get into a little bit about the microservices side right now, because we spoke a little bit about the REST endpoints and how you'll be designing REST APIs. Okay, before I get into the microservices questions, because you said you have also having some exposure to microservices, what are the different software architecture that you are aware with, Krishna? Like, what are the patterns or what are the architectures that you have already followed within the 4 years of work experience, like the projects that you have worked with?
Right. Majorly, I was involved with monolithic based projects. The recent project that I have worked on has microservices architecture, and slowly I think most projects are shifting or migrating to monolithic. Microservices.
Okay, no worries. Monolithic is also not bad. Okay, so you have mostly worked with Monolithic, and right now, a few projects you've worked with microservices. Are you aware about this SOA pattern or SOA architecture? No. Okay, not a problem. Can you just tell me the basic differences, Krishna, between a monolithic application and a microservices-based architecture application? Like, what are the major differences, and what thing you are trying to achieve in both of these things, or whether these monolithic things are bad? Do we completely avoid the monolithic application? As you said, we're right now migrating most of the time to the microservices based applications. So should we, let's say if I'm creating an application, it should be monolithic or microservices? Just tell me your viewpoints, keeping these questions in mind, and also just give me a solid comparison between this couple of software architecture.
Right. Yeah. And like Abhilash, you mentioned, I don't think that it is so easy to categorize without knowing the requirements that either microservice or monolithic. Basically,
at least you said like, no, go with the microservices. Okay, we cannot decide that. We have to understand your requirements, and accordingly, we should be choosing whether it should be monolithic or microservices. But tell me like the basic differences between these couple of things. Yeah.
Right. And the reason I'm saying that why not monolithic and microservices black and white is when we shift to a microservice-based architecture, it brings a lot of complexities within. And if the requirement is not such to have those complexities inbuilt, or the project itself is not so big, it is a pilot project or a POC, then it doesn't need to be that complex. Coming back to the basic difference between monolithic and microservice. So within a monolithic architecture, basically all the project is basically packaged in a single jar or war, right? We have modules in every project. We have modules, and those modules are basically segregated into packages in a normal monolithic architecture, and they interact with each other using the access modifiers available, right? So we have private, public, and default, and we also have protected. So with that, they are able to interface with each other. But the only problem with this is because we have everything within the jar or war, deployment jar or war becomes extremely bulky as the project size grows, it becomes extremely bulky. Deployment onto servers becomes an issue because every time we are changing something, the whole war or the whole jar is then we have to go through the complete CI/CD build pipeline. Testing is extensive because of this, because everything is so interconnected. As well as there are issues with respect to scalability, and that is something which microservices is very big on and very good at. So in case of monolithic, we have to, if we want to scale, if the requests are suddenly, for example, IPL season, we are expecting 3 times the requests, we have to basically scale the entire application, not just the maybe scorecard application or scorecard module. But with microservices, like comparing microservices are basically, there are different projects for each and every module, which basically we call as services. And the services interact with each other using Fain client or REST template, like basically REST calls through which they communicate with each other. Now, what this helps in with respect to monolithic architecture, how this compares, scalability becomes very easy. So if, for example, we have a situation where only one service needs to be scaled, we will just create copies of that service, and we will be able to scale it up. We won't spend an extra infrastructure to get 10 unnecessary services scaled up. Similarly, we will not have issues in the case of testing. So I think you had mentioned one very good example that I am from the scorecard team. I made some changes. I went to cafeteria, drank some coffee. Someone is laughing at me. I tested my part, but because of my part, something else got broken, which I'm not aware of. That kind of situation does not happen in microservices because service itself is self-sufficient. It is a boundary in itself, and we can communicate. And like REST APIs, it is what goes in, what goes out is clearly defined. So that is something which is really good. But the drawback here, in which my monolithic is better, is inter-module or inter-service communication, because it is happening within the same project, same jar, same war. It is very fast. But because in microservice architecture, you don't even know if they are on the same server, the services. There can be a situation they are on different servers. There can be a situation one server is behind API gateway, load balancer, and we have all the configuration, so that can take time.
So it's more than one network calls, like many network calls are going through.
Correct. Right. So it is not, coming back to the original point, it is not very black and white. Based on if the project is not so big, I would start with monolithic and then slowly, microservices.
Perfect. But when I'll be creating that application using the monolithic architecture, I should be also in future, I might migrate to the microservice architecture as well. But it's not like, I'm a startup and I have only few bucks in my pocket and I am going with a lot of servers, a lot of resources. I'll be bankrupt in a few days if I'm following the microservices architecture. Yeah. So yeah, perfect. Good example. But Krishna, here, I want to raise one point. You said you'll be dealing with many servers in microservices based architecture. And here, the things will not go that simple, because whenever you're working with a monolithic application, it's just like one call. Let's say you are making a call from the client, it will hit a destination, it will bring back the result, serve you that thing. But let's say in a microservices application, the call that you are making goes through number of machines. That's why we call it a distributed system, because your request goes through different machines. Let's say machine A, machine B, machine C, then the response comes back to the client. So here, as we are dealing with many machines, and as you said, you can also scale up things. Like there is a project, there is a scorecard application, IPL season comes, a lot of requests are coming to the scorecard application. So I created 10 instances of that. So in that case, how you will be discovering all those instances? Because there will be many machines involved. There are many servers involved. There are many instances are running through. So how you will be basically tracking all your instances, and how your discovery will happen, so that the calls can go through. Like what pattern you'll be using over here to discover your microservices.
Right. So, like you mentioned, because suddenly applications can scale up, scale down based on the demand. You can never predict what URL or what basically the server is, what basically the port number is for this particular service. So these things can't be hard coded, or these things cannot be in a configuration file somewhere, right? So we use something called as registration and discovery in a microservice. So what we basically do is using the application name or service name, we basically register the service to a server. I think it is called Eureka, right? We use something called as.
Let's not involve the libraries. Okay, let me just the concepts. Then we can think about the library later. Library we can Google and can use. Just tell me, yeah, this is how we can sort this particular problem. Yeah. So registration and discovery service, what it does, how it will help you to discover your microservices.
Right. So basically what happens is if there are 20 services, all of them, as they start up, they will register themselves to a repository, you can say, or to a page where it stores basic information like name of the service. Basically, if there are multiple parts of the service, then 1, 2, 3 it will append, and the host name, the port, and maybe it can also store details like endpoints, what endpoints it can have, right? And the discovery part of it is that we cannot hard code like host name or port values, right? But we can always know what service we are calling. So using the service name, we are able to discover what are the possible. These are the number of host or port numbers available, and I can call. And if there are multiple, we can have like client side load balancing also. So in that case, it will be able to select based on the load which endpoint which server or which service it wants to hit. So that is basically the pattern of discovery and registration.
Okay. So in one line, like if I want to summarize your entire conversation, it's just like we have some discovery server and we have some instances of a microservice. When they starts off, is connected to the discovery server and register itself. And that's how when all the microservices starts off, they fetches information from the discovery server, caches them with their local repository, and by the time it wants to make a call to any of the microservices, it has a cache available where it knows like how many instances of those services are available. And it's makes call, and you said like you can use load balancer over there, the client side load balancer. Well, I'll be coming into that, and it can make calls over there. But one possible scenario is I'll be telling you right now, Krishna, here, because based on the explanation that you have given, one question I'll be asking, just hear this out and tell me like what will happen. Let's say you said, let's say there is an instance of service A, there is an instance of service B. Let's say service A wants to connect to service B. Okay, so whenever service A starts, it fetches the information from the discovery server that, okay, how many instances of service B is running. Let's say it fetches like the 4 instances of service B is running in this IP and in this port number. So you can make call to any of these instances. Let's say service A picks up one instance from the local cache, what it fetched from the discovery server. And when it makes call to that particular server, to that particular service B server, that service B server is already crashed or no longer existed. Okay, at that time, the call will be failed or something will happen, because the call that we are making from service A to service B, we fetch the information where that service B exists from the local cache that we have fetched from the discovery service. Now that server that we are making call is already gone, is crashed, but it's still there in our service A cache. So in that case, the call to service A or service B will go, or it will fail and result in exception. And if it will result in exception, then that's a bad thing, right?
Right.
So what will happen over here?
There can be 2 situations here, Abhilash. There can be a situation where that service B is also dependent on some other service, and there is a situation where there's basically a blockade for response.
That service B is not dependent with any service now.
Okay. If it has basically failed.
Yeah, it's failed. But if it is failed means, let's say client is calling to my microservice. Now my microservice is dependent on service B. So it makes a call, picking a instance from the local cache, what it fetched from the discovery server. Now it found that there are 4 instances of service B is running. Okay.
Right.
So it can call to any of the service B instances, can get the result. But the one it picked, that doesn't exist. Now that is died, that has been killed. Okay. So obviously it will not find that. So it's going to be an exception, right? And the client will get an exception. But it should not happen, because we have already 3 service B instances available, which could get us the response, right? So here, what will happen?
So in this case, like you mentioned, the broken down service, we will get an exception, and the registration itself has a timer, like every 5 minutes or every some time, it basically re-registers itself. So exactly. Maybe later on, 5 minutes or 10 minutes later, that instance. This just
happens 30 seconds. And within every 30 seconds, it refreshes cache. So if it founds like if that service doesn't exist, it will not straight away give you the exception. Maybe within that 30 seconds, it has been already removed from the local cache of service A. So only 3 instances will remain. The 4th one will be removed, which is gone. Or if it is getting an exception, it will not straight away give you an exception. If you're using anything like Eureka or Console as a library, so it may it may face the new things, new fresh cache again from the discovery server, and from there it will pick one. It will make a call. If that is also failing, then there is a problem. So straight away the exception will not come. And obviously, as I said, a background thread will be there, which basically refreshes the cache in every 30 seconds, or any time. If you configure 5 minutes, 10 minutes, you can also configure for that, but the standard will be obviously 30 seconds. Okay, perfect, bang on. Now here is a new question. The question is, let's say you have a service A and you have a service B. Let's say right now the service A did a search from the discovery service, and it's found like there are 4 instances of service B available. Okay. Now service A is having a request right now, and it has to connect to service B. So there are 4 instances of service B. So how service A will make a call to service B? And you said there is some client side load balancing is happening in service A side. So what do you exactly mean by that word client side load balancing, and how it is exactly different from the server side load balancing.
Right.
Question is clear, Krishna?
Yes. Question is
Go ahead.
clear. So load balancing as a concept, like you mentioned, in scenarios where we have multiple instances of the same thing, then we have to load balance it. And even in cases where traffic is more, then we have to load balance the requests. So that is when load balancer is used. The difference between like a client side load balancer and a server side load balancer is, in a server side load balancer, we specifically have like a dedicated server, or you can say a dedicated service, which will be, rerouting requests. So if I make a call to service B, then it is the job of the server, of the server side load balancer, to basically route the request based on load. And then there are all things like there are algorithms based on which the load balancing happens, round robin, or we can have random.
Yes.
That also we can configure. Difference between server side and client side is, like, in server side it becomes a single point of failure. So in case if that service itself suddenly has issues, or is facing like a lot of requests and it is down for some reason, then we basically lose our entry point to any of the services, right? In client side load balancing, it becomes that the load balancing happens where the service itself is making calls. So each service, like in this case, we are doing service registry and discovery. So when it does discovery, it caches the details over here in its local cache, and that's how they are able to make requests. Like they are able to route requests, and same thing, round robin, and the different algorithms can be configured here also.
So here the service itself is making calls to the desired microservice. Sorry, rather than involving a server which basically holds a kind of router, or a load balancer which basically routes the request to another microservice. It's basically the number of calls are getting decreased in the client side load balancer, you have said. Yeah, and one thing, just Krishna, I will not say it's the wrong thing, but still one thing that you have mentioned, like in the server side load balancer, it's a single point of failure, because obviously all your requests will come to the server side load balancer, and from there on it's going to be routed to the desired microservice. But if the middle person is failed, that load balancer is failed, then the application is gone. So it's a single point of failure. That's true. But we can also have multiple servers allocated. So if one server is gone, another gateway will come, or another router will come.
High availability type.
Yes, exactly. We can also scale up those things. That is also possible. But yeah, it's a single point of failure. You can say if no router is available, the request comes and it is failed, it's crashed and gone. Yeah, so fine. Perfect. So I think we are good with these questions, right? Here, here we have one extra layer in the server side. In the client side, there is no extra layer. The client itself is making call. The client itself is doing the load balancing. So the number of network calls are also less. Can I know what kind of library you can use to achieve this in your Spring Boot and in your Java applications? The client-side load balancing, what I mean. Yeah.
Right. Like you mentioned, we have Eureka. I think we have Spring Cloud Server, and we have Ribbon. Ribbon was the one which Netflix introduced, which was outdated. And then we have Spring Cloud Server, which is basically doing the
Spring Cloud Gateway.
Gateway, sorry, yeah.
Spring Cloud Load Balancer. I'm wrong. Spring Cloud Gateway is different. Spring Cloud Load Balancer. Well, the gateway also does the load balancing, but Spring Cloud Starter Load Balancer or something like the jar is. But be sure that Discovery Service doesn't do the load balancing. Discovery Service job is only to do the service discovery. Well, the discovery service internally fetches in that Spring Cloud load balancer. That's why people think okay, the discovery service only is doing the load balancing, because I know the Eureka fetches that library, that load balancer library behind the scene. But yeah, these two concepts are different. Perfect. Very well answered, Krishna. And I hope that people who are hearing it, they will be getting a lot of benefits out of it. So going into the next thing. Okay, let's say there is a service A. There is a service B. Now service A is making a call to service B. Okay, and service B behind the scene making a call to service C, service D, service E, then it's fetching the response and giving it to service A. So whenever the client is basically hitting service A, the service A internally making a chain of requests. This goes through service B to C, C to D, D to E, and it's a chain of requests. Now let's say, as you already mentioned, like these are like deployed in different servers, because all these services are some independent projects that we have to maintain in a distributed system. And here the request will go through many different systems. There is a high possibility that one system is down. There is a high possibility is that one system have a very heavy network load. It cannot handle any request, or some server is running out of resources, cannot handle any request. Let's say one of the server in between this chain is not functioning well. Then obviously it will give you the error response to the client who is basically called that particular request, and it will break the chain. And the service A right now is going to give you an error response back, because the chain is broken by one of the faulty server in between. So in a microservices environment, there will be a high probability that you are making a request. The request is going through some of the servers. One server is failing, and due to that, your entire system crashes, and you don't get a proper error response back. You basically get an error response back where you should get something. So how you will be tackling this kind of failure situations? Because there is a high possibility that you are maintaining so many servers, there might be some problem with any one of the server. So how will you be basically handle this failure situations? Just tell me some of the valid options you can, or valid techniques you can apply over here to save your save your microservices and giving back the proper response. Yeah.
Right. So like you mentioned, Abhilash, we will get an error in that situation. And maybe because this is a pattern of microservices, chain of responsibility. So in that case, even if the error is handled properly, like proper error message is given, but because there are multiple services involved in the complete request, the actual error because of which microservices it failed will get like enveloped within multiple error messages. So it becomes difficult. So in that case, we should make our microservices resilient. And we use something called Resilience 4J in Spring, which is a library to make the microservices resilient. Now we have a lot of things how we can avoid this situation. First thing I think which should be like in every microservices, that there should be a default response. So in case if the service is unavailable, or if in case there are some issues with that service with respect to response, or maybe it is waiting for another service and it's not getting, in that case it will return a default response.
Fallback response,
right? And how else we can make our microservices resilient is we can use some patterns. Like one of the patterns is a circuit breaker pattern. So in cases like, I think circuit breaker pattern is used when a lot of calls are going to microservices which is unresponsive or failed. So in that case, we can have a situation where, say, supposedly after 10 requests, 10 simultaneous requests, if there's no response, we will turn the circuit off, like we will break the circuit. So there's no connection between it, and the response received will be appropriate. Like this circuit between these services has failed, like there is no response received. And on the back end, it keeps trying, and there is a threshold for that also, that after successive 5 or 10 successive requests, then the circuit again turns up. So these are a few things that can be done to make the services resilient.
So with the circuit breaker pattern, you are just cutting off the connection between the faulty microservices, so that you should not hit it again and again, and you should not allocate the resources for that. And you are giving some time to that particular microservices to recover. And then you are just tracking the things using the threshold that you have set. And after some time, you are again making the request, and you see like if the microservice is back live, and then again you are sending back the request to that. Otherwise, you are cutting off the connection and sending back a fallback response. So using the circuit breaker pattern, Krishna, you are basically doing what? You are basically cutting off the circuit, and you are not hitting that faulty microservices. You are basically cutting off the load to that microservices and giving time to that service to recover or auto heal. That's fine. But let's say there are some other things are also available. The other patterns are available, like retry pattern, like we have rate limiter pattern, like we have bulkhead pattern, right? So have you heard about this retry pattern and what it does? Can you explain to me?
No, actually, Abhilash.
It'll retry, Krishna. It'll just
Right,
retry.
right.
Let's say right now in the retry pattern, what you will do? It will be like, okay, now in the first hit, I didn't get the response back. Maybe the connection is not good, or maybe it is solving some other microservices and the resource is not available. So you are just retrying it for a couple of times. Maybe you're going to be getting back the response. So in one hit, if it is failing, instead of giving the failure response to the client, internally you just process that request for a couple more times and see like if you're getting a success response. And if yes, give it back to the client. If not, send him a fallback response as you have mentioned. The retry pattern, you are just retrying. Okay, before we go for the next question, here is a quick heads up. Let's say there are a couple of services, service A and service B. The service A has a couple of endpoints called /AAA and /BBB, and service B has an endpoint called /DDD. And let's say right now there is a request coming to service A to the /BBB endpoint, and now the thing is how this request will be processed further. And to make you understand that, first you understand every server has a thread pool, and this thread pool consists of a lot of threads like this. But you have to remember, all these threads are very limited and they're very costly. You cannot have many number of threads. For an example, in a Spring Boot application, you can have 200 threads by default. And these threads plays a really vital part to process your incoming request. For an example, in this case, to process this request, there will be a thread which will be needed to process this request. And this request lifecycle will be handled by this thread. So this thread will process this request further, and once the response will go back, this thread only will help to process the response and give it a response back to the client. And once the request response cycle is complete, the thread will go back to the pool so that it can be reused by another quest. So all these threads that we have, they will be reused, and we cannot have many number of threads. Just to remember that. Now just see a situation whenever there is a request comes to the /AAA endpoint. Now imagine this /AAA endpoint internally calls the /DDD endpoint of service B. Now to process this endpoint, we need this thread, and we will borrow one from the thread pool. Now this thread will takes the responsibility to call to the another endpoint of a service B, and whatever responses gives back, this is going to again come back to the same thread. And once the response comes back to this thread will give the response back and serve it to the client. And once the job is done, this thread will go back to the thread pool. Well, this is a happy scenario, but now let's just look for some odd points. Now, what if the server is down? Let's say there is one of the server is down. Let's say this service B is right now down. And in this case, whenever there will be an incoming request to the service A/AAA endpoint, one of the thread will be assigned, and this thread will again take the responsibility to call to the /DDD endpoint of service B. Now let's say this service is down. Obviously, it will give you a failure response because that request cannot be processed. And in this case, this thread will basically give the response back to the client or to the end user, which will be obviously error response. That's the connection is refused and we are not able to connect to the service B because it is down. Well, this scenario is still be manageable, but the problem will happen when the thread has to manage a slower service. For example, what if there is a slower server? For an example, the service B right now responding slow, and this is right now having some more and more traffic, and it cannot get us the result fast, and this is going to be a mess. This is going to be a horrible situation. For an example, now we get a request to the /AAA endpoint, which internally need to call to the /DDD endpoint of service B. Now this request will be processed through a thread. The thread makes a call to the service B, and now the service B is responding slower, and now this thread need to wait till it get the response back from the service B. Now this thread that you are seeing goes ideal, and it will be waiting for the response from the service B. Until then it is ideal. Now there is another request comes. So this thread is ideal, so we will borrow another thread from the thread pool. Now again we make a call to the service B, but remember the server is right now slow. It is not responding back quickly. Again, this thread also goes on waiting, and it is waiting for a response back. Now let's say there is another request comes. Obviously another thread we will borrow. Again, this makes a call, and it keeps on waiting for the response because it's a slower service. Now let's say there is a request comes to the /BBB endpoint. Obviously it's the /BBB endpoint doesn't have to call to service B, so obviously one thread will be assigned. It doesn't have to make any call to any external server, so it gives a response back, all happy. Once the request and response is completed, the thread goes back to the pool. But again, let's say right now there is a request comes to /AAA endpoint. Again, this thread is also assigned to that particular request that makes a call to /DDD. Now we do not have any other thread left to process any other request, and now this is a complete mess. Right now my service A cannot actually handle any other incoming request. Even though there is a request comes to the endpoint /BBB, this endpoint doesn't have to call any external service, but still this request cannot be processed because there is no threads left over here to process this request. Even though this endpoint doesn't have to call any external web services, still it cannot be proceeded further because we do not have any thread left in our thread pool. And now if any other request comes to the same /AAA endpoint, this is again makes the situation more worse, because imagine if after some time one of this thread got timed out because it is not getting any response back from the /DDD, immediately another request will occupy the thread which will go back to the pool. So like that, if we have multiple requests over here which are incoming to service AAA, it is basically going to wait for any thread to become vacant so that it can occupy that, and there will be a lot of requests in the queue. So after a while the service A is not going to respond itself, and this service is also going to be down. So the best thing that you can do whenever there is a slow service, you basically cut off the connection from the active service. For example, the service A is working good, so if this service is not working good, let's just cut off the connection for some time, let it heal, and once this is going to work good, this service is also going to work good automatically, and we will not be having any unresponsive threads like this, and we can get rid of this particular situation. So let a microservice heal, let a microservice recover when it is not responding. Give it some time to recover. Stop calling the slower microservice for a moment so that it can restore itself. I hope this understanding will help you to understand the next problematic situation that we will be discussing. Let's say, Krishna, there is a hacker. Okay. You heard about the brute force attack? What it does, like the...
Yes, denial of service basically.
Exactly. Let's say somebody is trying to knowingly, let's say if I am somebody who is knowingly increasing the load for your microservice. I'm continuously hitting, I'm just written some script. It is just continuously hitting your server and creating the load so that your server will crash and like your system will fail. How to protect this one?
I think you mentioned rate limiter.
Rate limiter. You're going to be limiting the rate. And you mentioned about the resilient force and using what you can basically, solve this particular things. Perfect.
I have one question, Abhilash. We have various ways to deal with these scenarios of microservices facing issues, but rate limiter and the first one, which is circuit breaker, we discussed, they sound like very similar. So in which scenarios we will use
a rate limiter and circuit breaker are not similar, Krishna. Circuit breaker is breaking the circuit itself. It is not
okay.
allowing any request. Rate limiter is not breaking the circuit. It is just limiting the rate. Like for 10 seconds, I will be only accepting this many requests. That's it. Any
Okay.
more requests to that, it will be failing. I'm limiting the rate, right?
Okay.
So that
Okay.
somebody knowingly cannot increase the load. So you have to choose the right pattern, whether it should be bulkhead, whether it should be rate limiter, whether it should be circuit breaker or something.
Okay.
But all these things related to the fault tolerance, how our microservices can tolerate the fault, and how we can just return the response gracefully. Instead of giving a failure response or an exception to the client, we can just return a graceful request, a graceful response. As I said, the fallback response we can just return if our circuit breaker triggers, or if our rate limiter triggers, or our retry pattern also triggers an exception, then we can just break it in a graceful way so that their application also will not break. Perfect. So this is a quick walkthrough if you're very new to circuit breaker design pattern. Well, let's just say if there is a service A and if there is a service B, okay? The service A is calling a service B, but the call here doesn't go directly. It goes through a person who is going to monitor the call if that is passing or failing. And that guy is the circuit breaker. And by default, the circuit breaker is in the closed state. Closed means the calls from service A to service B are allowed. So right now, if the circuit breaker is in the closed state, the calls from service A to service B are allowed like this. Service A can call to service B and the requests are going through because the circuit breaker is right now in the closed state. Okay, now look at this diagram. The circuit breaker is in the closed state. That means the call going through from the service A and service B are going to be monitored by the circuit breaker, and the circuit breaker allowing the request because the circuit breaker is in the closed state. But let's say now the circuit breaker monitors that some of the calls from the service A to service B are failing like this. Now circuit breaker understand that there is something fishy going on in the service B and that might be down, and I should not allow any of the calls to the service B because, as I said, we should avoid calling a service which is not functioning. Okay, so right now the circuit breaker noticed that and quickly changed the state to open state. So in the open state, the circuit breaker does not allow any calls from service A to service B. So right now, as the circuit breaker is in the open state, all the calls that you are seeing, the circuit breaker is working as a mediator between service A and service B, and it is not passing the call to the service B. So in this situation, the service A is not overloading the service B server by hitting it for multiple times. Rather, it is giving time to this to recover. But now the question is, as the circuit breaker is right now in the open state, how long it is going to be stay in the open state? How long this circuit breaker is not going to allow calls from service A to service B? Well, there is a time defined for that and we can configure it. Let's say for 10 seconds. So for 10 seconds, circuit breaker is not going to allow any calls to service B, but what will happen after 10 seconds? And this is how it goes. So let's say right now the circuit breaker is in the open state, so no calls are passing from service A to service B. So right now, after 10 seconds, the circuit breaker goes into a state called half open state. So as the name says, it is half open. So it is not completely open. The circuit is not completely open. The circuit is not going to stop all the calls from service A to service B. Rather, it is going to pass some calls from service A to service B. Now the question is, how many calls it is going to allow from service A to service B? So let's say for that we can define some criteria. For an example, allow 4 requests and check if 80% of calls are passing. Let's say 80% of 4, that is 3.2, let's say it is 3. So right now in the hop open state, the circuit breaker is going to allow the next 4 calls and going to observe whether 80% of that or 3 calls out of 4 is passing. So here it goes. The first call from service A to service B is passing. The second call is also passing. The third call, let's say it is failing. And the fourth call, it is passing again. So 4 out of 3 calls are successful. That means the service B is back online and we should allow right now the call from service A to service B. Now the circuit breaker changes the state to closed state. So in the closed state, as I said, the network is active. So the calls are right now going from service A to service B as usual. But what would have happened if the circuit breaker is going to notice more calls are failing in a hop open state? So right now, let's say the circuit breaker is in the hop open state, and as per the criteria set, it is allowing 4 calls from service A to service B, and it is noticing out of 4 calls, 2 calls are failing. And now the criteria set over here, out of 4 calls, 80% of calls should pass. That means out of 4, 3 calls should pass. Right now, out of 4, 2 are failing. That means the service B is still having some problem and it is not functioning correctly. Now, the circuit breaker changes its state again to open state, and it is going to further stopping the call to flow from service A to service B. And this is how a circuit breaker is going to help us to cut off the circuit when service B is not functioning well. Because as I said, we should not overload a microservice whenever it is not functioning well. We should give time to that to recover. Before I wrap up this question, as you have just told me about this thing a little bit, can you just tell me, Krishna, the circuit breaker, how it works internally, how many states it has behind the scene, the states of the circuit breaker, if you remember?
Right. So circuit breaker has states like open, closed. Open, closed are like major states. Half open, there's half open state also available.
Explain me the half open state. Why do we need this?
Right. So for circuit breaker, like open and closed, closed basically does not mean that it's closed, but closed basically means that the connection is active and you can make calls.
Okay.
And when we have successful failed requests, like above the threshold, it goes into closed state. Sorry, open state. And then, sorry.
Correct. Yes, correct.
And then there's some time period until it waits, and then it goes into half open state. So basically that after that time period, it analyzes the traffic going in. So it checks if some number of, like, the threshold value of requests are successful or not. If they are successful, then it goes again into closed status. If they are not successful, then again it goes into open status and waits for some time.
Perfect. So in the half open state is just monitor whether, let's say I'm going to be having 3 calls or 4 calls. Let's see if 40% or 50% or 60% of the calls are successful. If it is successful, means the service is back online. Let's keep on hitting it. Let's go back to the closed state and let's allow the traffic going in and let the call flow to the microservice. So there will not be any interruption. Bang on. Perfect. Next question, Krishna. There is a service A, there is a service B, and then a chain of requests. Let's say when the service A, let's say request is coming to service A, the service A is making a call to service B, and behind the scenes, service B is calling service C, service D, service C, and it goes on. So in the distributed system, the call can go through many different systems, many different servers. There may be many network calls. So let's say one of the service is functioning slower. One of the service is slow. Okay, it's not performing as expected. It's just giving you delay response time. Okay, and because of that, your entire request is taking more time. Okay, let's say if it is a monolith application, you said, okay, Vilas, you make a request, it's giving you the response in a flash because it's inside the one server. But here in the distributed system, the network request will go through many different servers, right? Let's say one server is down or one server is behaving slow. Maybe measure of the resources or threads are already blocked by the other resources. And because of that, it is behaving slow. Now, because of that server, your entire request response process is getting impacted. Now, you as a developer, how you will be tracking if there are n number of services, which service is actually performing slow, and how will be detecting it, and how will be fixing this issue.
Right.
How will be detecting first of all? How will be debugging this?
So the first thing, Abhilash, like even in my project, sorry, I have like train noise going on.
Okay. Let's wait for 1 minute. Yeah, gone, Krishna. Yeah.
It's gone?
Yeah.
Okay.
Staying in Bangalore?
No, I'm in Pune.
Pune, huh? Okay. No idea. Yeah, go ahead. Yeah.
So, like you mentioned, I have faced similar scenarios. Like in my current project, I was assigned tasks that this particular REST, basically REST API or REST endpoint or microservice is slow. Now we have to increase efficiency, and then I was assigned tasks for it. And it becomes really difficult because of the pattern you mentioned that internally there are a lot of calls, and based on scenarios, it makes those calls. It's not like one shot solution of everything. So first thing, like as a debugger, what we do is as a coder, as we debug, we first check that how much time it is taking. And if possible, we recreate intermediate requests and track that time. But even better option for this is a tool that I studied, which is Zipkin that you had explained about. So Zipkin basically hits those requests to each and every endpoint, and between each microservice, it gives us statistics on how much time it is taking and how much interval or how much slowness is available. Based on that, we can particularly, if there's an issue, always within REST APIs, there might be some issues, there might be some blockers, or maybe unnecessary data is flowing in. So that we can bottom down using Zipkin, and then we can solve it.
Perfect. So Zipkin will get you the statistics. Okay, that's the culprit microservice. That's basically taking the response time, giving the response time this much second or that much millisecond, which should not be there. And then you can just, let's say, if maybe a simple restart of that particular server can also kill all the resources which has been blocked, and maybe the things will go back to the normal thing, right? Well, using the Zipkin, I think in Spring Boot 3 is converted to micrometer or something. I'm not sure, but yeah, using that tool, you can basically fix this issue. And now let's say, Krishna, there is an exception. Imagine it's not a performance related issue. Let's say in a microservices architecture, a request is going through 4 or 5 different services, and in one service is giving you exception. Okay, then how will you track that? Which service has given you exception?
Tracking exception.
Tracking exception. So maybe see in your normal application, what do? You just see your console, right? And you'll be saying, okay, in my console, I have this exception. I have logger implemented. You get the exception. Okay, because of this, you go to that file, fix the thing. In microservices, there will be many servers. It's not one application, it's 10 applications. This request has went through, let's say 5 or 10 different applications. Now, how you as a developer will see all those things, because you cannot go to every machine and open that machine server console and go to the B machine, C machine, D machine. If you're going to do that, then the entire day is gone. And in the evening status call, you have to give what you have done. You cannot say, okay, I'm opening all the server consoles and seeing the exception and I haven't found any. So what you can do over there to check which is the exact culprit microservice where the exception is getting raised. So how can you say I have to go to the A project or B project or C project or D project or E project? Which project is basically giving you the exception?
I am not aware actually of this.
It's basically Krishna. You can just try to implement the logging thing. There is some tools called, if you heard about ELK stack. Even
Right.
I told that I'll be doing it and I have not done this. It's my fault. Yeah. ELK something you can implement. It's like Elasticsearch, Logstash, and Kibana. Kibana is a tool, or Splunk you can use. And they are in the Zipkin you mentioned, like, there will be statistics based on the tracing ID, right? So you can just pick up a tracing ID, because whenever a request has been created, one tracing ID is also created. So you just go to your console, copy the tracing ID, go to the tool like Kibana and paste that tracing ID over there. For that entire request flow, like whatever the microservices travels through, you're going to be getting the log for that request. A service, B service, D service, E service, everything inside that tool. So in one global place only, you're going to be finding everything. See the issue, go to that service, fix it, right? So you have to go through one of this tool at least. Like Zipkin you said for performance, these things you can use for your Splunk or Kibana for your logging thing.
These are basically SaaS-based tools, if I understand correctly, SaaS-based tools or SaaS-based or on-premise, which forward logs to a centralized location, right?
Exactly.
And then they help in searching and indexing.
Exactly. And that's why you'll be using the ELK, you are using Elasticsearch and the Logstash for indexing and all this stuff, right? And Kibana is just a UI, which is going to help you to gather all your logs in one centralized place. Going to be saying, okay, all these logs are here. All this requests travels through all these microservices. Well, it goes through A service, B service, C service, D service. Well, the E service, we have the exception. So let's go to the E service. Let's start the debugger over there and let's do a debugging.
Right.
Perfect. I think you are okay with the microservices stuff. So I should be happy with it. Maybe a couple more questions, Krishna. Can I ask you one question, which is not related to microservices? Let's just get out of that. I think you have handled the Spring Boot and the microservices questions pretty well. I just want to take you to the ORM frameworks. You said you are okay with Hibernate stuff. I just want you to explain me two things: the entity object and the value object. What is the major difference between an entity object and a value object? In which scenario you'll be using all these things?
Right. So like you mentioned, Abhilash, ORM, object relationship mapping. So what that framework basically does is that it maps objects or classes to tables within the database, right? Now the different type of objects you mentioned, entity type of object class, or value type of object class. The main difference between the two is if we mark a class as @entity, then basically there is an equivalent table which exists in the database for it. And we can, like you mentioned, we can have scenarios where we are using that table itself or that class itself, or we are embedding it into another class where we are using it as a subclass. So we can have those mappings, associations with the classes. And for value type of objects, these are basically objects which can be like classes which do not have underlying tables. They are just, for example, if there is a student type of class, student table will exist in the database, but student address can be like a complex object. It can have temporary address. It can have a permanent address, which is not necessarily stored on the database side, but it needs to be represented as a complex, like user defined class as an object. So in that case, we use value type, and they can be embedded. We can also have collections which can be value type. We use @embedded and @.
So Krishna, if I will summarize, so you said for anything what we need a table, there's going to be an entity.
Correct.
But for any classes, what we don't want to store it in a specific table, but we want to store it as a part of something, some entity, then there's something which is called a value type. And you have given an address example. Let's say there is a student entity, which will have student ID, name, blood group or something. There is an address entity, which has student address details, let's say lane 1, city, zip code, and all these things. Let's say if you want to make address an entity, what you will do? How can you differentiate? This is an entity, this is a value type. There is one major difference. I got it. Whatever you said it is perfect, right? The table thing that you have said. Now you said like Abhilash, here, if the address is not an entity, then there will be one table for student. In that table, you'll be storing the student details, student entity details like ID, name of the students, blood group, and then the address thing. Let's say address 1, lane, city, zip code, everything will be coming under one table. But let's say if address is an entity, it's not a value type, then it will have its own table.
Correct. It will have its own table, and then there should be association like join column and foreign key should be present.
So if it will be a different table, the major difference is going to be what? The ID. ID. The value type will not have an ID. The entity type will have an ID. That's the important difference. And if it has an ID means it will have a specific table. If value type does not have an ID, then inside the student class itself, it will have a reference to that particular class, like address, this dependency the student class will have. Now the student class is containing or owning that address object. And if the student class is gone or the student object is destroyed, the address is also destroyed. So the major difference will be if you want to store the student details and the address details separately, then go with the entity type. Make the entity type for both of the objects. If you don't want to store the address when the student is destroyed, then make it as a value type and attach it with the student entity. Don't create a entity for the address. Okay. For an example, there will be some real estate, what we say, those property dealers, right? For them, the address is really important. Maybe for me, if Krishna is done with my course and Krishna is going out, maybe I'll not be needing the details of Krishna. But let's say if I'm property broker, okay, and you have already registered with me, that means even if I die, I will not be deleting your address, isn't it? I will be needing your address till I die, because you may make up your mind to purchase the property anytime, right? So at that time, the address is needed for me. So I will be making it an entity. But let's say I'm selling courses. Let's say Krishna is done with all my courses, is done with all of my courses. Now Krishna is going. I'm sure if Krishna is going, Krishna's details I'll not be needing. So I can remove Krishna's details. That means the address details also will be removed. But if I'm property dealer, that means I'm removing Krishna's details, but address details I can still store as a different part of the table. And based on the situation, you have to make sure like whether you have to make it as an entity type or a value type. But perfect. Yeah. The example you have already given, I think I should be okay with that. One last question, Krishna. Just tell me about one-to-one mapping. How can you set up a one-to-one mapping in Hibernate or Spring Boot? What are the major things that you'll be taking care of? What is a one-to-one mapping? Explain me everything and we'll wrap up.
Right. So like you just mentioned, Abhilash, right? That we in scenarios where we want to save the data, where the data type is important based on requirements, we will have entity-based objects, right? And there should be some association, some way to link these objects together, right? In case of our example, student and address, there should be some way to link them together. And I think we have multiple types of associations that define a relationship between the entities. One of the starting or most basic examples of an association is one-to-one mapping. What one-to-one mapping basically entails that for every row, for every object within the student entity, student table, there will be one and only one object or row in the address table. So a student cannot have multiple addresses, an address cannot have multiple students. Basically, that is what the relationship one-to-one mapping defines. And this is very like, I would say, tightly coupled type of relationship, one-to-one mapping. Now, how we would be able to set up this into Hibernate, into our Spring Boot application, would be that while defining, we have to, in other type of associations, we have to define like the owning type, owning side of the relationship based on the one-to-many type of scenario. But in one-to-one, anyone can be the owning type because it does not matter really. But
the foreign key can be stay in either side.
In either side, right? So when we are defining the foreign key, for example, we can create it in the student side. So we take student ID, name, maybe other details like blood group, courses taken, and we can have another like reference object for the address table, address class. So we can have a private address, and this will basically become our join column, or this will basically become our foreign key to reference objects from address. Now, how we make it one-to-one mapping in Hibernate is we reference it with two annotations. We do @join column and we do @one-to-one mapping to it, and then we define like we define basically, I think, the ID for it. I'm not sure. ID.
The foreign key ID, the property name.
Right, property name over there, which basically makes sure that we are having this relationship, and this would entail a one-sided relationship. So if we only want to reference the address when a student object is called, then that is when we will do this. But if we want to do it the other way around, like address, when we are calling the address, student should be called, then we have to do a bidirectional relationship. So we have to define the join column on the other side also. So that is something. And then we can have cascading, that if the student object is deleted, all the operations basically of performed on student should also happen on the address side. We can also select like selectively which things should come into picture, which things should cascade. But we can set to one like this.
Should I confuse you a little bit? What do you mean by the cascade type refresh?
Cascade type refresh would be, I think, and this is purely my assumption, that based on refresh, I mean, when we are refreshing the student type, maybe for some cache or some other purposes, I think with respect to maybe the proxy object, I'm just taking a guess.
Go ahead.
In those scenarios, the cache for the address also should be refreshed.
You are refreshing the parent, the child will be refreshed. That's what you're saying. And if it is bidirectional, it will go either way as well. Perfect. Let me not confuse you on that, because otherwise I'll be also confused after that. After some time, if I start thinking about it, then I'll be like, okay, well, even I don't know about this. Okay, let's just skip it. All right. So yeah, Krishna, I think we're good. All right. So last question of the interview, just let me know about Exchange. So what do you mean by Exchange in a message broker like RabbitMQ or Kafka or ActiveMQ? Explain me this term Exchange, what it is, and why do we need it in a message broker like RabbitMQ?
Right. So like you mentioned, we have multiple message brokers. We have JMS, like the most basic one. We have RabbitMQ. We have other ones. So the main concept behind this is that requests are basically, there's a producer consumer model which is being implemented, and the requests are basically stored inside a queue, and the producer produces a request, stores it into a common queue, and then the consumer is able to basically sequence it like in a queue, last in, first out. So in that fashion, consumer is able to consume the request and simultaneously give a response to it. So I think it involves a microservice pattern where we are dealing in producer-consumer kind of a fashion.
Exactly. And exchange is something where we are basically broadcast our messages, and the queues are basically attached to the exchanges, and this basically grabs the message from the exchange. That's the simple concept. Well, happy with everything, Krishna. And I think I had a great time having the couple of rounds with one with core Java, one with this Spring Boot and microservices. Very well prepared, I must say. And I'm really happy. I think the people who are watching this interview will be also finding it really, really helpful. But yeah, don't go with both of our conversation thing. You also do some research and find out maybe we could be wrong in some places, but yeah, I will also make sure whenever I'll be editing, I'll just check out few things. I think you have answered everything really, really in a nice way, Krishna. I might be wrong some places, not sure. Well, I think I'm happy about it, Krishna. Anything else you want to add? Anything you want to ask? Everything good?
I'm good. Yeah, I think I'm good.
Perfect then. Then we should wrap up. Yeah. Perfect. So great then, Krishna. Thank you very much for giving your time, and great talking to you. And I think, people will be finding it beneficial in our community, the paid community, and also if it is going for free, like to YouTube or somewhere, I think they will be finding it really well as well. Well, maybe we can meet with another mock whenever you'll be prepared well for some other questions. And once we learn some of the more advanced thing. That's it. Thank you very much, Krishna. Have a good day. Bye-bye.
Thank you. Thanks, Abhilash.
Good night, by the way. Bye-bye. Bye-bye, Krishna. See you again.
Bye.
All right, guys. So that's all about this interview. I'll see you guys in the next video with another mock interview. And yes, the part 2 of this mock, the core Java part, you can find it shortly on Selenium Express YouTube channel and also on my website, which is www.seleniumexpress.com. If you like this video, make sure that you are liking it, you are subscribing to the channel, and you are sharing this video with your friends. And that's it. So I'll see you guys in the next video. Till then, bye-bye, take care, and happy coding.